Hello friends, this video on triangles part 36 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 35. Ratio of area of two similar triangles is equal to ratio of square of their corresponding side. This is a theorem. That is, if you take area of triangle 1 and area of triangle 2, let us say triangle 1 and triangle 2, you say area of triangle 1 by area of triangle 2. This is side of any side you take AB, and here you can have PQ, square of this ratio, square of ratio of their corresponding side. We will prove this. So to prove this, we know that area of triangle ABC is nothing but 1 by 2 into BC into AM. Correct? Also, we have seen in the last example that ratio of side altitude is equal to ratio of sides, that we have seen actually. Correct? So what we can do is area of triangle ABC by area of triangle PQR is equal to 1 by 2 into QR into PM. 1 by 2 cancel. This is nothing but BC into AM by QR into PM. Correct? We know that AM by PN, ratio of altitude, is equal to ratio of side. We take any side, that is BC by QR. So instead of AM by PN, we write BC by QR. That is nothing but BC by QR into BC by QR. This is nothing but BC square by QR square, or BC by QR square. Also, we know that if the triangle ABC are similar, AB by PQ will be equal to BC by QR will be equal to AC by PR, right? Sides are similar. Therefore, instead of BC square by PR, you can say that area of ABC by area of triangle PQR is equal to, instead of BC by QR, I can write AB by PQ. It becomes AB by PQ square is equal to BC by QR square. This is also equal to AC by PR square. Correct? Area of these two triangles are, ratio of area of these triangles are AB by PQ square. You take any two sides, you take the ratio and you find the square, that is equal to ratio of area of these two triangles. That is the theorem. Correct? How this is equal to this? This we have proved in the last slide. If you have not seen, watch the previous video. That is ratio of altitude is equal to ratio of side. So here, please make a note. Side is the key factor. Ratio of areas of two similar triangles is equal to ratio of corresponding side. Similar to this, the next theorem, the ratio of area of two similar triangles is equal to the ratio of corresponding altitude. So in the last slide, we have proved that area of triangle ABC by area of triangle PQR was equal to ratio of their sides, that is AB by PQ square, right? Ratio of side square. Also, we have proved that AB by PQ is equal to AM by PN. Ratio of sides is equal to ratio of altitude in the previous videos. So instead of AB by PQ, I will put AM by PN here. So this becomes AM by square. So we can say that ratio of area of two triangle is similar to ratio of the altitude. Similar to this, we have ratio of the area of two similar triangle is equal to ratio of their corresponding median. Same thing here. See, we have proved that area of ABC by area of PQR, that is equal to AB by PQ square, that is we have proved. Also, we have proved that AB by PQ is equal to AD by PM in the last slides. That is, ratio of sides is equal to ratio of altitudes theorem. So instead of AB by PQ, I'll put this here. So this becomes AD by PM square. So we can say that ratio of area of two triangle is equal to ratio of the median square. Similar to this, we have ratio of area of two similar triangle is equal to ratio of the angle bisector. Same thing here we'll do. Area of ABC by area of PQR. This is equal to AB by PQ square. Known to us, right? We know this. Also, we know that AB by PQ is equal to sides, ratio of sides is equal to ratio of angle bisector. That is AD by PM. This is angle bisector. This angle is equal to angle, this angle, right? So instead of AB by PQ, I'll put this value here. So this becomes AD by PM square. So ratio of area of two similar triangles is equal to ratio of their corresponding angle bisector square. Correct? So we can say that ratio of area of two triangle is equal to ratio of side square, ratio of median square, ratio of altitude square, or ratio of angle bisector square. All are same. All are same. Let's take some example. ABC and DEF are two similar triangle and the areas are 64 centimeter and 124 centimeters. If EF is equal to 15.4, we have to find BC. So let's draw this triangle first, right? A, B, C, D, E, F, right? So we are told that, we know that ratio of area is equal to ratio of side square. So ratio of area here is, this is 64, 121. This is 64 by 21. 121 will be equal to ratio of side. We are talking about EF. EF is nothing but 15.4 here. And BC we have to find, this is X, let's suppose. This is nothing but X by 15.4 square. Or I can say that X by 15.4 is nothing but root over 64 by 121, that is 8 by 11, or I get X is nothing but 8 by 11 into 15.4, that is nothing but 11.2 centimeter, and that is my answer. Very simple. Ratio of area of two triangles is ratio of side square. Ratio of area we found 64 and 121. Side square is X by 15.4 square. We got X is equal to 11.2. We'll take one more example. Diagonal of a trapezium APCD with AB parallel to TC intersects each other at point O. AB is equal to 2CD. We have to find the ratio of the triangles AOB and COB. Let's draw this. This is the trapezium ABCD with AB parallel to DC, and this intersects at point O. Correct? It is given that AB is equal to 2CD. If AB is equal to, if CD is equal to X, AB is equal to 2CD, that is 2X. We have to find the ratio of triangle AOB and COB. We know that this triangle AOB is similar to triangle COD. We know this. Why? CD is parallel to A. We have done this question so many times. This angle is equal to this angle. A is equal to C. D is equal to B. Why? Alternate angle. And this angle is equal to this angle. Vertical opposite angle. So let me write this in triangle. This and this. We'll write first. Angle AOB is equal to angle DOC. Vertical opposite angle. Angle OCD is equal to angle OA. Sorry, equal to angle OAB. Why? Alternate angle. Correct? Since they are two angles are equal, we can say that triangle AOB is similar to triangle COD. Now since they are similar, we can apply the theorem, that is ratio of area of two similar triangles is equal to ratio of side square, right? So I can say that area of AOB by area of COD, all capital actually, COD is equal to AOB we have 2x and COD we have x, both square, that is x is cancelled, 2 square, that is 4. So ratio of the area of two triangle is 4:1. Very simple. The first thing, prove that the triangles are similar. Once the triangles are similar, then only we can apply the theorem, that is ratio of area of two similar triangles is equal to ratio of side square. We have applied the theorem. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.